Okay, welcome everyone. I am Delia. I hope you can see me, but I'll be hosting this revision webinar today for EC2065. Hopefully it will be a useful revision for you. We'll touch on a selection of topics and comment on the exam. So the plan for today is to essentially go through a few mock exam questions and what might be the best way to approach them, give you an overview if you haven't seen this sort of format yet. So if I can ask you to, okay, first, if I can ask, if you have any questions, please feel free to interrupt me at any point. I will be using a tablet for annotations, so I'll try to keep track of, any messages that come in, but if you have an issue or, need a clarification, please truly just feel free to speak up. And then, we'll address it as fast and immediately as possible. Okay. So, of course, this is a session meant for you. So whatever, in a way, works for you best, we should do. Okay. So having said this, let me see if everything is fine. It's a few minutes after 12:30, so we should probably start. So before we go right deep into the exam questions, the mock exam questions themselves, let me show you, perhaps, in case you haven't seen it yet, the format. The format included in the mock exam is the same as the final exam. So I definitely recommend that you accustom yourself to it. And, in this way, you will not be surprised when you're not surprised. You will already be familiar when you sit down for your exam. Of course, past problem sets first, mock exams and past exam are the best way for you to prepare for your exam session. So let me just share this. Hopefully this will go. Okay, there we go. Yeah, perfect. So this is, as you can see, your mock exam. This is for macroeconomics, EC2065 mock exam for this year. As you can see on the first page, I don't know if you've taken this exam. Actually, let me zoom out. On the first page, you have a short description, essentially, of what this exam will be. Okay, so definitely be familiar with what the format of the exam is before you sit down. That's something, that you can do beforehand, and you'll have it off your mind, essentially. So this is how it is for this exam specifically, right? We have two sections. Okay, we have a different set of questions. Section A contains short questions that are realistically faster to answer and a bit of a different format, perhaps, of the longer questions, right? It's a bit more reasoning of what you consideration of what you already know, application of the theory you have, while perhaps the longer ones are a bit more quantitative. Importantly, all the short questions from section A are mandatory. They carry 8 total mark of 8 points each. While for section 2, you'll have the long questions. These are typically around a page long each. You have 3 of them, and you only need to answer 2. Okay, if you answer 3, you're just wasting time because only 2 will be accounted. Okay. So in this sense, even for yourself, it's a good approach to think about your strategy on the day of your exam, because of course, time constraint is an issue, right? So you want to come in with a clear head. Specifically for this exam, you're allowed a total of 3 hours for the writing part. You have, however, 15 minutes before the exam starts for reading time. Why is reading time? It's the time where you can literally read, no writing, right? So I would suggest to use this time to kind of, first of all, read through the whole exam, make sure everything is as you expect. And perhaps it could be a good idea to already think about which questions you want to answer for section B, okay, where you want to choose, and ideally already know in your head how you want to proceed. Okay, so do you want to do the short questions first, the long questions? Absolutely, since I said you have quite possibly realistically a bit of a time constraint, give yourself some hard time limits just in case you get stuck. You want to move on to another question. Perhaps you can go back to it later. Of course, if that works for you, you can start thinking about, recalling the relevant theory to be applied, thinking about how to answer the questions. Importantly, keep in mind during this reading time, however, you're not supposed to write down anything, okay? So use it as you see fit, but, it's a good, come in prepared. My advice is come into the exam prepared with already strategy in mind. During these 15 minutes, kind of implement it, think about the 3 hours that you have next, how you want to structure, how you want to approach the questions. And then, once the actual time for the exam starts, just, it's pure implementation, go question after question and, resolve from there. Okay, now to the questions themselves. You see, you have section A first, the short questions. They're fairly short, literally. And you need to go through all of them. Today, due to time constraints, we'll try to go through approximately half of the mock exam, which reflects, I guess, also the time that you have available for the exam. We'll probably do the first 3 of these short questions, okay, and then we'll move on to a longer question, okay. Again, have the format of the exam clear in mind. From section A, you need to answer all 5 of the questions. Then here, section B, you have 3 long questions. As anticipated, you only need to answer 2. Okay, so you can see these are quite long. They're usually about a page, okay, but it's a lot of context, right? Kevin really walks you through the setup, and you see you have several follow-up almost questions, right? Incremental questions. So it's definitely my advice would be use your reading time to kind of go through all of them to make an informed choice on which ones you want to answer, right? Because the sub-questions vary quite a lot between the sections within each, right, question. So from A to E in this case. Okay, so for example, here we go, we have an OLG question that varies quite a bit. Then we have a diamond deep model. This is the question we'll do together today. And then, yeah, a question on the Newtonian model. Okay. Any questions on this? Otherwise, we'll start from the tackling the exam questions. Everything clear? Of course, if there are any technical difficulties, like you cannot see my screen, hear me, or see what I'm annotating, please let me know as soon as possible. Okay? Yeah, all good. Right. So let me stop sharing here and come here. 1 second. I just need to find something. The right slide set. Bear with me. Sorry, I just taught another class, so I need to find the blank. Okay, here we go. Okay, now I'm going to share this screen. Okay, perfect. All right, so here we go. Perfect. So that's it. Review. We're going to tackle these short questions first. Everything based on this mock exam. Okay. Once again, if there's anything you want to clarify, please let me know. Is everything working so far? Can someone just speak up or send a message? Yes. Okay, thank you, Jay. Right. Okay, so let's start with this. Okay. So question 1, here we go. It's a true or false question. Okay. So as it typically is, you have a statement that then you need to comment on whether it's true, false. You could even say uncertain. Okay. And importantly, as it always is with this kind of questions, you need to explain your answer. Okay. This is arguably the most important part of your answer, even more than getting the true or false right. Right? It follows that a simple true or false answer without an explanation is really not considered an answer. And possibly, if you have a good explanation with the wrong answer, that's more valuable. Okay. So let's read this statement. If the government raises the income tax rate in a tax system with a proportional income tax to pay for an increase in spending on public services, then there is an unambiguously negative effect on household supply of labor. So the first step always is to think and understand which framework, theoretical framework you need to have in mind and how to answer, to be able to answer these questions, right? Here we're thinking we are looking at an income tax rate and then household supply of labor. So a reasonable choice seems to consider a standard, the simplest even possible model of consumption leisure choice. Okay, but before we go a bit deeper into it, let me perhaps highlight that whenever you have very absolute statements, okay, such as here, you have this unambiguously. So unambiguously, always, never, right? There are very extreme statements. You always should be a bit alert, right? In economics, as arguably it is in life, hardly ever anything is always or never true, right? So in this sense, it's perhaps easier to answer these questions, right? For a false, for example, because it is enough to, in a way, invalidate this statement to find a counterexample, which can often be a very successful strategy in answering these questions. Okay. Of course, it needs to be, first of all, accurate and then motivated, but that's exactly what we're going to do now. Okay. So, as said, let's consider consumption leisure choice. We're keeping it here really as simple as possible. Here I have written the simplest budget constraint that applies here. So I'm looking at a household that likes to consume, doesn't like to work, would prefer to rest and consume leisure instead. But H for hours worked, right? If I work, I get paid a certain salary W, which I quite enjoy because then I can spend on consumption, right? We're in a context with a tax rate. So that's why I have this 1 minus tau multiplier before. This is essentially giving me, obviously the fungible income that I can spend on consumption, hence this being my budget constraint. Okay. So how does the working hours relate to leisure? Of course, my time allocation here is fixed. So I'm either working or I'm resting on the couch, right? Given, for example, a day, I need to split it between rest and work. I cannot, work less than 24 hours a day. I cannot work more than 24 hours a day. This needs to be exactly one. Okay. Otherwise, right, we're looking at a case where with very standard preferences, where I like to consume, I like to leisure. That is to say, consumption and leisure are normal goods to me. And it's a standard, even micro 101 choice of allocation between two normal goods. Okay, so that's why I represent it in this two-dimensional space on the right. With consumption on vertical axis, leisure on the horizontal axis. Okay, here, as discussed, the horizontal intercept must be at 1, right? Because I can at most spend the whole day, for example, resting in this case. It follows that the complement is spent working, right? Given this equation here. Then what's the converse? If I spend the whole day working, right, 0 hours leisuring, then I'm exhausted, but I get a total income of 1 minus tau W, right, because H is equal to 1. This is my vertical intercept. And otherwise, this really represents my budget constraint, which has a slope exactly here, minus 1 minus tau W. Okay? Right. Now, how do we usually solve this? This is just a setup. Okay, we'll spend a bit of time, but it's quite important, and it comes up essentially throughout your course, right? And so also throughout your exam. So how do you usually solve for this? This is just your constraint. You'll have some preferences as a household. We said, yes, we do like consumption, we do like leisure, but how much, how little, how do they substitute? This will give me the shape, right, of my utility function, the shape of my indifference curves here, which are important because we usually maximize, right, and we find the solution as the tangency point, right, between the highest achievable, for example, let me call this utility level U0, highest achievable indifference curve, and this budget line, right? This tangency point would give me the optimal leisure consumption bundle that I decide to consume given my preferences and my budget constraint. And this point, geometrically, as said, is the tangency point between the budget line and the highest achievable indifference curve. Okay. Mathematically, what is this? And you remember this from your, again, Micro 101 course or from the optimality condition of the household problem. This is given to you by an equality of the slope of your budget line here, so minus 1 minus tau W, for example, and the ratio of the marginal disutility, say, of labor over the marginal utility of consumption, right? This is the optimality condition, algebraically speaking, okay? Left-hand side, minus 1 minus tau W. This is the slope of your budget line. At this point, the slope of the budget line is exactly the same as the slope, right, of the line tangent to the indifference curve. Okay, this is the right-hand side here. This gives you the slope of the line tangent exactly at this point. The same you would have, obviously, at any other point. Okay, this is where we start. Here drawn a bit better, right? Here's with a negative because, of course, we're looking at negative slopes, but algebraically, we're going to get rid of it. This is the condition that we are considering, okay, where we're starting from, the optimum. The point I would just commented on is this A, right? Okay. Now, finally, to our question, right? What are we considering here? We're considering an increase in the income tax rate. Okay, so tau increases in here, which means here, my left-hand side, my available income actually drops, right? Because I need to pay more to the state. What before held with equality then means well, before held with equality, now holds with strict inequality, okay? So geometrically, what does this mean, right? I'm saying the slope of my new budget line is actually lower, right? So geometrically flatter than the tangency point at which I was at, okay, this A, the line tangent to A to the indifference curve. Economically, what is this 1 minus tau W? Yes, it is my available income, but it is also the opportunity cost, right, of leisure. If I'm resting on the couch 1 hour, it means I'm working an hour less, okay? I'm earning a wage W less, but in my bank account, this shows up as a 1 minus tau W, right? So now the opportunity cost of staying at home is actually lower, right? Which means leisure is relatively cheaper compared to consumption, okay? This is my, remember, ratio of the prices. Technically, this is over 1. 1 is the price of the good. Remember how we normalize everything, right? So with the leisure becoming relatively cheaper as a rational household, what do? I substitute from consumption towards leisure. Okay, so that is to say I move southeast, okay, in this graph. Oh, sorry about this. Am I back? No. There you go. Sorry. Southeast, right? Less consumption, more leisure. I'm moving along this original indifference curve. I'm saying with unchanged preferences, just from a change of prices, I'm substituting from consumption to leisure. This is my substitution effect. How much am I substituting exactly? I need to find a new tangency point, right? So this is my compensated budget line. I want to find on this original indifference curve the point that has a tangent line with slope exactly equal to my new budget line. So say this is here, right? Okay, say my new budget line looks like this. Right? Flatter. I first look at the compensated one. So on my original indifference curve, I have a new tangency point, which is here, that indeed gives me lower consumption. This is a negative substitution effect on consumption, and a positive one on leisure, okay? Because leisure is relatively cheaper, okay? This is my substitution effect. However, because I need to pay the government more for every dollar that I make, I am also overall poorer, right? This is my income effect. This is your inward shift of your budget line, which, given the fact that consumption levels are normal goods, gives me a negative effect on both. How do I find my final new allocation? I need to find a new tangency point between my new budget line and the highest achievable indifference curve. This will give me an updated lower level of utility, right? And apologies for my drawing. In a second, you'll have the LaTeX ones will be more accurate. You see that, of course, the income effect is strictly negative for both, okay? Right? And this new point, say C, this is B, gives you the final effect, the sum of the two, okay? So, of course, that's why we're interested in. Why are we doing all these shenanigans? The question asks us whether an increase in the tax rate unambiguously gives us a negative effect on the household supply of labor. Here I'm trying to find a counterexample where this is not true. That is to say, labor increases, leisure decreases. Okay, and you see here already that you have these two offsetting effects between income and substitution effect. And really, then what matters is which one dominates. Okay, formally, let me try a bit better. As said, we have an increase in the tax rate. This flattens your budget constraint. Okay, you have a substitution effect. You find on the original indifference curve, the point whose tangent line has slope exactly equal to your new budget line. Okay, this gives you positive substitution effect on leisure, negative on consumption. Okay, then on top of this, you have the income effect, which is instead negative, you're poorer overall. So positive substitution effect, negative. Here in this example, you have an offsetting effect for leisure, right? That brings you overall at an L2 here, L2 star here, which is lower, okay? For L lower, given the fact that you're either working or leisuring, this essentially means you have an increase in employment in work, right? Which is the opposite case to the statement in true and false. So this is enough to show that the statement is not always true. That is to say, word for word, it is not true that an increase in spending on public services leads to an ambiguously negative effect on household supply of labor, right? This is coming, you see. The effect on consumption, it is unambiguously negative, right? Both substitution and income effect push consumption downwards. But the effect on leisure, which is what we're interested in, right? Leisure, because tells us about labor, is instead ambiguous. It could be either way. Here we have considered the case where the income effect dominates, so that you have a overall decrease to provide a counterexample to your true and false statement. But obviously, it could also be that the opposite is true. So let me give you just an example for both. You see that the approach will be the same. What changes here is just the preferences, and you can see it from the shape of these two indifference curves. Okay, the budget line here is your original budget line. It is the same. You have on the right simply a flatter indifference curve. Okay, that is to say the two goods are more substitutable. Okay, you can think of it as how much do I need to give up to increase of one good to increase the other, right? And you see that the step here is much lower. Okay, so how does this work? Same steps as before. So increase in tax rate. This gives me a flatter budget line. Of course, my x-intercept is still at 1 because I can still decide not to work. And if I don't work, I'm not taxed. And I just spend my whole day on the couch and eat nothing, right? So it's flatter. First of all, let me identify the substitution effect by looking at the compensated budget line. So that means that I'm trying to find the point on the original indifference curve that has as a tangent a line that has exactly the same slope, right, as my new budget line. You see the slope of these 4 blue lines are exactly the same. Okay, you see, of course, the approach is the same, but given the shape of the indifference curve, here we have a different overall effect. You can already see it, right? The substitution effect here, it is, of course, negative for consumption in both cases. Okay, reduces consumption in both cases. And of course, it increases leisure in both cases. Okay, but you already see here that the magnitude, the level is much, much, much different. Okay, you see, we're comparing essentially this to this. Okay. what happens? Yeah, let me maybe rely on the graphs that are better than my own. Okay, so this is substitution effect. You can see it in green, and really this is the change in magnitude, right? Because then on top of this, we have the income effect, which is the same. Ultimately, the new budget line is the same for both. And you see that for leisure, these two offset each other, right? And the question really is by how much, right? So in the case we already consider this one on the left-hand side, the income effect dominates. The income effect dominates. You see that the difference here leads to an overall decrease. Okay, so overall, your leisure decreases, the sorry, this is an H. Your labor increases, labor hours supplied. Okay, this is the counterexample to the statement in your true and false, from which you can conclude that the statement is false. But of course, the opposite could also be true. Okay, here on the right, instead, you have two offsetting effects still of income and substitution effect, but the substitution effect dominates, right? Overall, you have a positive increase in L. You go from here to here, right? Here, you go south, east instead. Okay, so your leisure in the second case increases, which would mean that labor supplied decreases. Okay, so it's not always either or. Okay, it is enough in this case to provide a counterexample. So why did I go through all of this? To make it clear to you, but also to remind you to always be careful and consider all possibilities. Wait, I realize now there's a message. So the income effect is what led to the new budget line. So the income effect is what led to the new budget line only, and a lower indifference curve. The substitution effect only has the effect on the old indifference curve. So, Jana, I hope. The effect is as follow. So you have an increase. Let me try to work on this that has a cleaner picture. The effect of the tax increase, okay, and hence you landing on a new budget line is the sum of both, okay? So income and substitution effect. This is what leads you from this first allocation to this one. Okay, let me stick to the right panel. Just this is the sum of both, and you can see it on the vertical and horizontal axis by the green and magenta arrows. Okay, then how you find them? Yes, for the substitution effect, you work only on the original indifference curve. Okay, so this is going from here to here. This is your substitution effect. How do you find it? You need to know the slope of the new budget line. So you see, it's not the new budget line itself, but it's only the slope and the original indifference curve. Okay. And then the income effect is the parallel shift. Okay, between the new budget line, the solid blue, this one, and the compensated, this dashed one. Okay, so this is income effect, substitution effect. Okay. And the effect of the tax is the sum of both. The effect of the tax is the sum of substitution and income effect is what leads you from this point A to this point B and the new budget line. Okay, is this answering your question? Is this clearer? Yes. Okay, great. Any other question before we move on? No? Okay. Let's move on then to question B. Sorry, question 2. Question 2. And you see how Well, Kevin's very kindly already gives you always the question structured in this way. But even if it didn't, you probably need to identify these three components, right? So typically, first, you need to have clear in mind the theoretical framework, the model you need to have in mind to answer this question. Here it's given to you. Consider the solo model without technological progress. Very good. We know where we're working. Then context. Suppose the economy has converged to a steady state where the ratio of investment to GDP exceeds the share of income received by owners of capital. Capital income as a share of total income is equal to the marginal product of capital times the capital divided by GDPY. Okay. Then the actual question. With reference to the golden rule, explain whether the economy is saving too little or too much if the goal is to maximize consumption per person in the long run. Okay, so this is precisely what the golden rule is, right? It identifies the steady state capital, well, per worker here, since this is our context, that maximizes consumption. Okay, so maximizes consumption, of course, here again per worker. So context, we had a clear mind. Sorry, model framework. Context, this is, and then the actual question. Okay, so now we know what the question is about, okay, about this golden rule. What is the context? It's given to me here. How do I translate it? There's always two sides, right, to economics, the words, the stories that we tell, and how we tell them is often also paired with math, right? So translate the two. Okay, so what is this telling me here? This is just telling me that the ratio here of investment to GDP, so I over Y, exceeds the share of income received by owners of capital, so is greater than the marginal product of capital MPK times K over Y, the capital intensity. Okay, so this is where we are within the solo model without technological progress, right? And we need to connect it with the golden rule. Okay, this is how we go from one to the other. Okay, now what is the golden rule level of capital per worker? We know this is given as a solution to the following. Sorry, it's sorry about this. You have the marginal product of your capital here at the actually let me just say golden rule equal to D plus N, right? So more formally, this is what the golden rule is, right? And we need to relate the two. Here I have it written here. It's great if you remember, right, what this golden rule is, okay? Don't panic if you don't, right? As long as you remember the definition and you also, are given it essentially in the text, right? It tells you here that the golden rule allows you to maximize consumption per person in the long run, so in the steady state. Okay, so recall what we're looking at here. Okay, so let me start with the nominal variables. I'll denote them with capital letters. Everything is about capital in these models, right? This is the dynamic variable, what governs everything. Okay, so typically, how does capital evolve? The capital you have tomorrow, it's what is left over from today, the undepreciated share of your stock today, plus however much you add, right? This is your investment. In this question, we are looking at variables per worker, okay? So I'm going to divide everything by the population, L. This is K prime over L equal to 1 minus D K over L plus I over L, okay? So from here, then how does this evolve? you look at the little k here, denoting capital per capita, okay? Tomorrow is given still by the undepreciated, what's left from today. So that's the net of the capital today, net of depreciation, but also net of population growth. Okay, that's where this n comes in. Why? Because look at this. I need to divide it by the total population. If the population is growing, I will need more and more capital, right? And then, of course, I need to add what I invest. And we know that in these models, this is constant share, okay? Constant share of output. And we denote this share by S, right? So F of K, cursive K, okay? S is the proportion, okay, the part of total output invested. F of K denotes my production function, right? Let me be more precise. I think you denoted with Z outside, okay? Right? Now, we're looking at the long run, so at the steady state. We know that in steady state, capital is constant, right? That's its definition. And of course, then from capital or other variables as well. So capital, of course, per person, per capita is constant. So let me denote with a star, the steady state. Let me rewrite the above in steady state, this one. What am I saying? That capital tomorrow is going to be the same as today. So 1 minus t minus n, the level of today, k star, right? Plus y invest, so s, z, f of, again, k star, right? You see that here I can simplify, which gives me that essentially your investment here. Let me just denote it by what I is equal to d plus n k. Okay. This is your E. I. Okay. Okay. So see how we had several. We're in the solo model. We consider that. We're looking at the long run. That's why we consider steady state. And now that's where we need to get to the golden rule. Okay. We have it there written, but what if we didn't remember? The golden rule is maximizing consumption per person. I know that consumption each period, right, is whatever I don't invest, right? I split output between consumption and investment. So if I invest a share S, how much am I consuming? Oops. How much am I consuming? A share 1 minus S, right, of my total product. So that's ZF of K, which means, let me expand, ZF of K. And then now I'm substituting this as ZF of K. This is what I just found before for investment. What is this? This is exactly D plus N K, right? Then if this is consumption, okay, in steady state, I know this is maximize. Actually, I'm sorry, let me write it here. Maximized for which K? Well, I'll just take first order derivative with respect to K at better. What is that? Z, the marginal product of K, right? Here, I'll put GS to remember this is already the, GR, this is already the golden rule solution, equal to, or better, minus D plus N, this level of capital, equal to 0, right? This is first order derivative set to 0 to find the maximizer, okay? And I know that this level of capital maximizes my consumption in steady state. This is exactly what my golden rule instructs, okay? Now, how are these two related? You see, of course, you can rearrange this to get exactly the golden rule that we have here at the beginning. That's that alphabet K. Oh, yeah. Well, I'll put a star there, but D plus N K. Okay. Oh, sorry. This is a typo, of course. Linear, you don't have this term. Okay, just D plus N here. Okay, this is your golden rule. You know that the capital level that satisfies this is your optimal level. How do you go from here to, how do you go from here? What is going on here? Oh, sorry, something is up. Okay, I hope you had everything. If not, let me know. I'll share something else. Where were we? We reached this solution. How do we go from here to here? Let me just multiply both sides by the capital intensity, K over Y. Okay. And this, of course, I know that D plus N times K, we found it before. This is just your investment, okay, which gives you the right-hand side here. And this is on the left-hand side, we have the capital intensity, right, times its marginal product, which is the right-hand side here, which is the right-hand side, the left-hand side here, okay? So we're saying that at the optimum, according to the golden rule, actually, this should hold with equality. Instead, we are in a situation where this the investment is greater than its optimal level, right? Which means I am investing. Okay? According to the golden rule. Is this clear? Okay. Yep. Okay. And you see also how to remember what the golden rule is. Here it's still equating, right? At the optimum, how much you're gaining every period from capital, right? This is just your marginal product, and how much you're losing. This is due to depreciation and population growth. Okay, so should be not too hard to remember. Okay, all clear? Huh? Okay. Now, then moving on to our third short question before we tackle the longer one. Again, same structure. Immediately, we have the theoretical framework of reference. Suppose firm would like to pay efficiency wages to motivate workers who would otherwise have an incentive to shirk. So it's a labor model, right? Where you have an asymmetry, right, of information between employer and workers. Workers just want to get paid, essentially. Let me be blunt, brutal in this sense, and exert as least effort as possible. While obviously on the other side, the employer wants to maximize efficiency, right? So this is the context we're in. Now, what's the context? This is the model we're in. What's the context? If W is the wage and E of W, this is a function of W, is the amount of effort exerted by each worker. You see, this is how much effort am I exerting for a given wage, right? If I'm paying like 5p per hour, I will not probably put my best effort. Then the profit maximizing efficiency wage, this is the point of view of your firm, is the solution to the following equation. Okay, this is giving you optimality in case you didn't remember, right? And now finally to what we need to do for this question. First of all, we're given an explicit functional form from our effort given wage. This is a log function in W, right? The wage with an A term. This is reflective of the monitoring. It's a constant, a positive constant, right? It's a monitoring that your employer kind of exerts. Okay, you can see it is increasing, right? The more I'm controlled, let's say, by my boss, the less I will slack. Okay, first of all, this is part one of what we need to do. We need to find the efficiency wage, okay, which we're told up here solves this equation. Then part two, okay, we'll split it in two. We need to think about what happens when I'm better monitored. Okay, so I said here, if A increases, what will happen to the efficiency wage? W, remember, we just found it in part one, and unemployment. Okay, so now we'll just step into it. I reported the two, basically the information that we're given so that we can use it. And now we'll approach part one and two. Okay, importantly, we know, first of all, we need to find the efficiency wage. Here we're told it solves this equation, right? Effort in this specific case takes this functional form. So I have E of W already. Of course, W is what I need to solve for. It's my variable. So what I need, first of all, is E prime of W. Right? What is this? This is just the first derivative, right, of your effort function with respect to wage. How much harder will I work if I'm paid what dollar more? Okay, but we're given this equation. This is A plus log of W. Okay. What's the derivative with respect to W? A, of course, is just a constant. So this is 0. And then I have derivative of the log. This is just, oops, this is just 1 over W. Okay? Right. Now, given this, I have everything I need, right, to find the efficiency wage. So let me just substitute in this formula here. So E prime of W, I just found it. This is 1 over W. I already put a star here because I'm already solving it. I know that the solution to this equation here is the efficiency wage. Okay, before it was just a generic W. This is the variable. I can take any value. This is a specific one. It's the only one that satisfies this. Okay, so back to us. E prime of W is 1 over W. At this level, I have W star. Then equal to E of W. What is this? This is A plus log of W. Again, W star over W star. Okay, here we're assuming, of course, the W star is non-zero, which is realistically even positive, so we're fine. But for completeness, we'll just note it down. Okay, so this also allows me to simplify here. What I'm left with is 1 equal to A plus log of W. Okay, rearranging 1 minus A equal to log of W. What is the log? The log is just the exponent that I need to give to my base to obtain W, which gives me my efficiency wage W star as E to the 1 minus A, right? And with this, I've answered the first half of the question. Okay. Ooh. Now that I have this efficiency wage, I can answer the second part of the question. I can tell what happens if firms can monitor workers better and reduce shirking. That is to say, increase A. Okay, better monitoring. This is where we're at. Okay, so always, again, let's translate the English into math. What does that mean? I want to know what happens to my efficiency wage when I change my A. So the derivative with respect to A of my efficiency wage. But the efficiency wage I just found, so this is just E to the 1 minus A. What's this derivative? This is just minus E to the 1 minus A. Okay, which is, of course, negative. Okay, so I know that my efficiency wage will decrease. First part. What happens to unemployment? Unemployment will also decrease. Why? Remember what unemployment is. People trying to work and not finding work, right? They want to work, they can't. So unemployment is, if you think about the labor market, essentially the difference between supply, those who want to work, and demand, those who offer jobs. Here we're at the optimal level, right? As a usual standard supply demand dynamics, right? If the wage, the price drops here, okay, if I'm paid less to work, I'll just decide to work less. Okay, supply is lower. If instead I'm on the demand side, this is cheaper inputs, I will demand more. So you see, this is a difference, which means that unemployment unambiguously also drops. Okay, which answers our question 3. Okay, questions on this? No? If it's all clear, we'll move on now to question 7. So if you have it, just perhaps pull it up, even though we'll go through it. This is a question about the Diamond-Dybvig model. Okay. So we'll do a quick review of the setup there. Let me perhaps read some of the setup, which is also given to you as a question in the question. So, deposit at commercial banks are one of the main forms of liquid assets held by the public. Okay, in the Diamond-Dybvig model, a large number of risk-averse households each saves 1 unit of income in period 0, but does not know when the savings will be spent. Each independently has a probability T, each household that is independently has probability T of being an early type who needs to consume in period 1, or the complement, probability 1 minus T, to be a late type. That is to say, they're patient and I can wait until period 2. The type, however, is private information and is only revealed in period 1. Okay, so here's already a lot of information. Okay, we know we're familiar with the Diamond-Dybvig model, but regardless, what are the key ingredients here? You have households that are risk averse. Okay, this is going to be playing a key. This is going to form a key channel for this to work. Okay, and then there is uncertainty. Okay, about the household types. Okay, you know they could be early or late, but you don't know who's which, right? Which is why, as a bank, what we're going to consider now, you need to cater to them both in the same way. Okay, you cannot discriminate. Now, in terms of timing, okay, as we said, we have 3 periods, 0, 1, and 2. Where you can, and in period 0, you can decide what to do with your money, essentially. You have, let's say, a unitary amount to invest, and you have by yourself as a household 2 options, the one depicted here in this table, okay? You either decide to invest it, so this is period 0, right? Everyone has to say. If you decide to enter an investment, you wait until period 2, and you get a total return. This is a gross return, right, of 1 plus R, where R is positive. Okay. If you leave, however, the investment early, you get no return. You get 0. Okay. So this investment is illiquid, but has positive returns. Okay. This is the trade-off. It gives you more, but you need to wait. What's the alternative? The alternative is that you basically just keep cash, okay? Stash your cash either under the mattress or you put it in a bank, and that's your bank account. You put in 1 today, you'll have 1 tomorrow, or 1 in period 2 if you decide to wait. Okay. Importantly, note this period 1 and period 2 columns are alternative. Okay. Right. Okay, so you see that now, especially given the risk aversion and this time uncertainty, there's a role for the bank to play. In fact, a commercial bank can create deposits, right, that offer different returns in period 1 and 2 to the different households. Okay, so the role of the bank here is essentially twofold, right? You have one, the maturity transformation, okay, kind of solving this problem here of wanting to invest but not having the time or the patience to wait until period 2, but also obviously taking on the risk if there's any. Okay, so given two types, and remember the early types need to consume in period 1, there's no uncertainty here, they will have to have something here. And then you have the remaining portions are late types. These household can wait, okay, emphasis on the can, to consume on period 2. This does not mean they might not decide to consume in period 1, okay? And so you need to be very careful about that. How do you do that? Okay, as a bank, that's exactly what you want to consider, right? So you decide to offer a deposit contract here in blue. These are listed essential listing of this is essentially listing the options of the households, right? A third option to investment. Oh no, please me. I'm sorry, I don't know what's happening today here. Okay. A third option to investing or just keeping your money, which is to deposit to the bank. Okay. Specifically, you deposit $1 today, okay, in period 0, and then you can either decide to withdraw D1 in period 1 or D2 in period 2. Okay. So comment here. You want, okay, as we said, there's no uncertainty about the early types. The early types will consume in period 1. Okay, this is certain. The late types might wait until period 2, and you want this to happen. So how do you incentivize them? You set D2 as a list as greater than D1. Okay, in this way, you incentivize the late types to postpone consumption. Of course, it goes without saying this only works if the late type believes they will get the money in period 2. Okay, and this hints at the second sub questions I will have, which is about bank runs. Okay, but for now, we'll assume everything works perfectly. Okay, but also note here on period 1 about the early types. It is true that the early types need to consume in period 1, but we also want them to enter this contract. The only way they will enter is, of course, if D1 is greater than 1, what they can get by themselves just stashing, right, cash under the mattress. Okay? This is our setup where we're going. So this is what my bank is targeting. I need to design a contract that allows me to do this. Okay, how am I doing this? Let me take the point of view, right, of the bank. I have T early types that will, if enter the contract, they will deposit 1 in period 0, if you want, period 0. And then withdraw, I need to pay them D1 in period 1, okay? 1 minus T late types that also deposit 1, and then withdraw in period 2. Okay, I want this to happen. Okay, how am I going to finance this? Well, I want to keep liquid the money that I need to pay the early types in period 1. Okay, so I keep this in reserves. And then finance instead the late types with the investment project. That will give me some positive returns in the second period. Okay, so the question of the bank is how to allocate the funds between these two. Okay, and you know that. Okay. Because banks also operate in a competitive market, then they will be making zero profits, and their zero profit condition is given by the following, which is also in your text. Okay, You see here, for T early types, I'll pay D1, right? For 1 minus T late types, I'll pay D2, but it's in the future, so I'll discount it by this return, okay? Or better, I will get this return from the project. So in present value terms, I need just D2 over 1 plus R units, okay? And this sum up to the total, which is 1, okay? Clear? This is the setup. We spent some time on this. Yeah, okay. If not, please just speak up, okay? All right, so finally to our question. If this is clear, now we'll go much, much faster, okay? We need to illustrate the zero profit condition, so what we just had here, in a diagram and explain how the equilibrium deposit contract is determined when competition among banks ensures they make zero profits. Okay, so this is to say the zero profit condition we've just seen is valid, holds. And then the question, why do sufficiently risk-averse households prefer D1 greater than 1 to directly investing and obtaining consumption equal to 1 as an early type or 1 plus R as a late type? That is to say, let me rephrase this. Why, if you have households that are risk-averse enough, do they prefer to enter the contract with the bank to either keeping their money in cash if they're an early type, this is paying them 1 in period 1, or investing as a late type, which gives 1 plus R in period 2. Okay, so let's do this. Okay, how do we illustrate this? As said, the ideas are always the same, methods are always the same, it's just a different narrative, right? So perhaps, unsurprisingly, we are still in this two-dimensional space, okay, with D1 on the horizontal axis, D2 on the vertical axis. What I have depicted here horizontally, the straight line is just my zero profit condition rearranged, right? This is how I go here. I'm just isolating D2, right? So let me subtract TD1 from both sides. So this is 1 minus T D2, 1 plus R equal 1 minus TD1, right? And then multiply both sides by 1 plus R over 1 minus T. Okay, which gives me exactly this this rearranged zero profit condition. Okay, this is what I'm depicting here. Okay, and you see here then you have, the slope. This is T1 plus R over 1 minus T. Okay, with a minus, negatively sloping. The y and x intercepts, right? And blah, blah, blah. Okay, you can calculate this as well. But importantly, and you can substitute within this equation as well, you will see that this point here, what is this? This is giving me 1, right? In period 1 and 1 plus R in period 2. These are the two, this reflects the position of the household, right? Without the bank, without entering the contract, right? Because I can get 1, this is the investment, right? If I invest directly and I decide to redeem early, I get 1, what I put down with no return. Okay, if I wait until period 2, I will get 1 plus R. Okay, what about actually if I keep the cash? Okay, if I just keep cash, I'll have 1 every period. Okay, this is your fiat money option. So you can check this investment point is indeed on this budget line. Substitute D1 equal to 1, D2 equal to 1 plus R, and you see you'll have an identity. It holds there, okay? Now, This is my zero profit condition as a bank. But of course, as a bank, I don't have preferences, right? I'm just an entity. What matters is what my customers, okay, my households want. Okay. So we said by themselves, they can enter the investment contract. Okay, this is this point A, for example. Okay. What about if they enter a contract with me, they deposit with the bank? Okay. Then they will get a certain D1 in period 1, a certain D2 in period 2. When will they enter it? When rationally they're better off, right? So this happens whenever they have preferences of this sort. Okay, so pardon my drawing again. Assume this is a tangency point. Okay, say this is what I offer. This is my contract, D1 star, D2 star. Okay, why do they enter? Because they're better off. Okay, so you can see that compared to the indifference curve they were originally on, this U0, they are at a higher level. That is to say, better off. Why? Because they are risk averse. What's the risk aversion here? This is the curvature of your indifference curve. Okay, so they are better off entering the contract. Indeed, they land on a higher indifference curve. Okay. Let me show you a bit of a prettier graph just because this is, as said, the investment. This is my contract. And you see, you have an increase. Is this clear? Okay, we're a bit slower, so I'll move on. Right, so this ideally is what happens. However, with a positive, with a D1 greater than 1, there is also bank run equilibrium. We need to explain how this happens, okay? So what do we know? D1 is greater than 1. We have n households, 2 types. We want to prove that it's rational to have a bank run. That is to say, everyone withdraws in period 1 and the bank fails. Okay, take the point of view of a late type. So if everything works out in this situation, you just wait until period 2 and collect D2, right? However, everyone but you decides to withdraw early. Okay, and you need to know that or suspect that. And note here doesn't matter whether it's really true or not. Okay, this is a self-fulfilling prophecy, which is what's really risky, I guess, about this. So let's review where we're at. This table represents the position of the bank, right? So we have these 3 options, right? And the bank collects the funds in period 1, in period 0, and then needs to pay D1 in period 1 and D2 in period 2. But we said 2 important things, okay? D1 here is greater than 1. It's more than people deposited, okay? So for each dollar deposited, I need to pay something extra back. However, how much can I get back in period 1? Only the amounts of funds that were initially deposited, right? Because fiat money doesn't pay interest by design, and the investment only pays interest in period 2. Because if I redeem early, I get nothing, right? I just get what I put down, right? Which means that the bank can obtain at most N, right? The initial funds in period 1. Okay, you see the problem. Because if total withdrawal demands are greater than what I can collect, put together, then I need to declare bankruptcy, right? You see that then, and this is always true for a large number of households, okay? So you see that here then there is an issue, because then going back to me, the late type who hasn't withdrawn yet, then I know that the bank, 2 things, will be unable to meet demands right now. But this means that even more so, the bank has no more money left for period 2, which is when I would have happily withdrawn D2. Okay, knowing this, so this is basically going to be 0. Okay, knowing this, I also want to withdraw today. Even the bank, if the bank is already failing, I might not get the full D1, but a portion of it. Something is better than nothing. So if I truly believe everyone is withdrawing, this is the bank run, then rationally, I will also decide to withdraw early. Okay. And this is the rationality of a bank run. Everyone will withdraw early, essentially. Okay? Clear? Now, in the few minutes that we have left, let me go through other things. Please, as usual, just interrupt me because I will check the chat a bit less. Now we have a change in this environment, specifically 2 changes. One, the central bank begins paying an interest rate on reserves. 2, to finance this, the government levies a tax. Okay, so that each household now has less to invest, right? They need to pay T to the government. Okay, so 2 changes. Okay, interpreting D1, D2 as what can be withdrawn from banks in exchange for depositing 1 minus T. Now banks only hold TD1 over 1 plus I in reserves. Okay, this was the allocation problem that we mentioned before. You know that before, let me denote this by prayer. This is TD1 only. Okay, so now we have a new zero profit condition, okay, which is the following here. You see that in period 2, for the second period deposit withdrawal, nothing has changed, but you have this extra term here, the denominator for the first period payment. Why? Because basically the central bank is subsidizing, right, this payment. And of course, then overall, you have less funds. And this is really what we need to think about now, because we're asked to think about the change of the gradient and position of the new zero profit condition. Okay. And note there are 2 changes again. Okay, so to avoid any confusion, I'll consider them separately. Of course, what I'm interested in the end is the sum of the 2, but it's a slippery slope. It's easy to get confused if you do them both together. Okay, so let's be systematic, dissect the 2 effects. I'll skip some steps in the interest of time. We rearrange, right, the new zero profit condition, and you see that we have a term here and a term here for T and I respectively. Okay, here depicted on the right, you have the initial, right, zero profit condition, the original one. Now you see immediately from the algebra that with the tax rate T between 0 and 1, your intercept, vertical intercept, will be lower, okay, by a factor precisely of T times 1 plus R over 1 minus T, right? Your new your new budget line will be shifted downward from the T effect only. Okay, but let me separate them maybe as we go through. But as a kind of preview, what happens to the gradient? Here is the second change. You have the gradient, what's multiplying D1 here. This is what we had before, and now it's divided by 1 plus I. I is positive, so it's scaled down. It's going to be flatter, okay? Now, let me dissect the 2. So I'm going to ignore the interest rate now. A higher T means a lower intercept. This translates in an inward shift of your zero profit condition. Okay, you 1. The effect on the household is negative. Why? This is a pure income effect, right? Which is negative and reduces what you can afford either period. Okay, indeed, the optimal D1 and D2 are both lower. Okay, note this is a shift. Why do I highlight this? Because now I'm going to ignore the T effect and focus on the I. This is changing the gradient. Okay, as said, this becomes flatter. This is a tilt. Okay, and see terminology here changes. Okay, here note, as said, I'm getting an interest on period 1. Okay, so here it means that I'm changing the relative price of d1 over d2. Okay, this is the same as the first question we had. We have a substitution effect. Here I find the point, okay, on the initial indifference curve that has tangent line with the same gradient as the new one. And you see that indeed this substitution effect is negative for D2, positive for D1, okay? And then an income effect as well. This is also positive. Why? Because, for every dollar I'll get that I put in deposit, I'll get an extra I from the central bank, okay? And indeed, you have an ambiguously positive effect on D1 and an ambiguous effect on D2 that once again might depend on your preferences, which here are reflective of your risk aversion, okay? Okay, now we're told that to finance this new policy, specifically the tax is set as ITD1 over 1 plus I. And we need to show that the new optimal contract would have made the bank 0 profits also before I and T were introduced. What does it mean practically, mathematically, geometrically? This point satisfies the initial 0 profit condition, okay? Lies on that line. And then from here, we can deduce how the two bundles compare and whether households are better off with I, okay? So new 0 profit condition as before, this is what we know. How do I prove that this is indeed the case? I'm just going to substitute, okay? Hopefully I have enough time. I hope this doesn't cut off. I'm basically substituting t in here, right? So I have t d1 over 1 plus I. Let me already add t on both sides. This is it d1 over 1 plus I. This is your t, right? Plus 1 minus t d2 hat over 1 plus r equal to 1. Notice what this is. This is 1 plus I t d1 over 1 plus I. This simplifies 1 minus t d2 1 plus r equal to 1, which is indeed the expression of the 0 profit condition. Let me put a 0 that we started with. So you can see, yeah, let me look into, I thought you guys had the mock exam again. Let me make sure you get this, but as we finish. You can see that this is the initial 0 profit condition, and as such it is D1 hat, D2 hat are indeed satisfying it, okay? Which means D1, D2 satisfies the initial 0 profit condition, and the households are not strictly better off with just the interest rate, okay? And then just because we're really short on time, the last part of this big question asks you whether the payment of interest on reserves reduce the bank's incentives to engage in maturity transformation and reduces their vulnerability to runs. I know this is similar to your true and false questions, so adopt the same approach. It should be fairly easy to answer given everything we've done together so far. Please be careful and notice that this statement has 2 components, okay? So check them too. One is on maturity transformation, and one is about the vulnerability to bank runs, okay? Any questions I can take quickly before we end? And I said I'll make sure you get this mock exams posted. All good. If that's all, I'll just then say goodbye. Oh, I can check. I believe it's gonna be on the recording of this Zoom class should be on your course webpage, the same where you usually get the the seminar recordings. Okay, but I'll make sure you get you get notified when it's posted as well. Let me just follow up on this after the call. And then for question 3, does it have to be solved all mathematically or can it be done theoretically using graphs as well? So question 3, I already forgotten what this is. Question 3. I mean, the graphs are really just the counterpart, right, to the math, in a way. So in a way, your question, Malak, is kind of the same, to me. But I believe if you're accurate with the graphs, that should be fine. I'm not sure for the first part, right? You're asked to find the profit maximizing efficiency wage, right? So I imagine for that you do need some algebra. Otherwise, oh sorry, I just realized my thing is off. You do have to answer the use some math. Okay. So, Shelomith, I'm not sure what you mean by the question as well. So if you could tell me, that would be great. And then we need the exam on the recording, please. Yeah. Yeah. So, okay. I'll make sure you get the mock exam. So these are the questions that we just went through, okay? That you will receive communication of it for both the mock and the recording, okay? For everyone, and then they will know, the admin will know who I'm talking to. Okay. And now I just realized there are some more questions that I didn't see. Yeah, so mock question, I answered already. Do I need to draw both scenarios in the exam? This is, I guess, in reference to the first question. No, for the true or false question, in this case, would have been enough to find the counter example and answer false, for example, or even without the graphs to tell me that it is ambiguous, the effect. I just showed it for completeness, okay? The recording will be uploaded. Yes. Can you please show the first question on screen? Yes, I will do that in a second. Do I always need to show the substitution and income effect in the Diamond-Divik model as you did in part C? Or can I just show how the difference curve at the non-banking equilibrium point is lower? And the deposit contract give a higher IC. What did I do? Sorry, my memory at this point is oh, I see. Sorry, but part C was about the tax and the interest rate, right? The previous one, part A, this is the Diamond Divig, is if it's just to show that the households are better off with the contract, then you can do so just graphically. That is true, but there's no, I would say, income substitution effect there. If there is, I think you don't have to show it graphically, but definitely should be part of your answer if whoever asked me this was interested in that. Okay. Right. So last thing before we leave. Of course, if you need to go, feel free to go. Someone just asked me to see question 1, so I'll just do that and then say goodbye. Okay, so let me see. Question 1 here. Question 1, this one, whoever wanted it. This is the statement. Okay, I think this is fine. I don't know if you needed the answer. This is the answer. Okay. Okay. And okay. Now I'll just leave you. Where will the revision content be updated? I said I'll just make sure you receive a communication on this. I'm not the one that actually posts this, so I'm not sure how to answer this question, but I would imagine it's on your usual course page. Okay? And with this, I already kept you over time, so thank you for staying. And I hope this was useful, and good luck with your exam and your revision. Be systematic. I'm sure you will do great. Okay? Have a good one. Bye. Oops. There we go.